Hi, my name is Tracy Haxton. I'm a Technical Director at Wallingford Hydrosolutions, and today I'm going to introduce you to WINFAP 5. As I'll only be focusing on the updates to WINFAP 5, it's assumed that you are familiar with the statistical method and WINFAP 4. If this is not the case, then I would advise you to look at some of our other online tutorials which will provide a background to the methods within WINFAP. Due to the nature of the changes within WINFAP 5, mainly relating to the way in which the data is managed and used, WINFAP 5 is not backwards compatible. However, so that users can view and work on older projects, WINFAP 4 will be able to be installed side by side with WINFAP 5, and license keys will be provided for both the software on purchase. The technical guide will now be published online rather than within the software, and to anyone familiar with the FEH technical guide, it will be very similar in a wiki format. This makes it easier for users to navigate and also allows us to update it really easily in the future if required. There are two main aspects of WINFAP that have been updated within WINFAP 5. The first encompasses the changes we've made to data management, and the second relate to updates to the methods. I'm going to start by covering the data management enhancements first. As previously mentioned, there's been some fundamental changes to the way in which data is managed within WINFAP 5. First, the input catchment descriptor file will use the more robust XML format. In the latest version of the NRFA peak flow dataset, version 10, XML files are provided alongside the CD3, AM and POT files. The XML files within the NRFA peak flow dataset contain all the catchment descriptor information required for both WINFAP and FEH, and later this year there will be a release of FEH which can use these files. In WINFAP 5, the NRFA peak flow dataset is treated as a master data source and remains unchanged. This is achieved through a manifest file which checks all the files within the designated peak flow dataset folder and ensures that these are unedited. We manage the peak flow datasets through the peak flow registry, and this allows us to have more than one peak flow dataset registered at any one time. However, as we accept that it's important that users are still able to introduce and edit data within the flood estimation process, we've added a number of features that allow users to do so. So first, you'll be able to edit station data within a specific project, and any site where data has been edited will be flagged with a star. In addition, you'll be able to add in additional stations, and these can be created or edited and subsequently exported, and they can be used within the project through what we're calling the supplementary folder. So any stations from the supplementary folder will be flagged with a plus. In this way, it should be very clear whether data has been edited or added within any flood estimation. Stations are managed within the station manager, and this contains all the sites within the NRFA peak flow dataset and the supplementary folder. As sites are identified by their site number, then if a site within the station manager has the same site number as one within the peak flow dataset, then this data will supersede the latter. If the site of interest has the same site number as either one within the supplementary folder or the peak flow dataset, then this will be in the station manager and the data at the site will be used in preference to these other sources. A project can then be saved within a project XML file. This saves all the settings and results from a pooled analysis and allows you to share details of projects, both within and between organisations. So any user, whether or not they've got access to any of the additional files or edits, will be able to open the project and see all the settings, methods and data from a given analysis. We've also introduced a project summary HTML report, which could be converted to a PDF or copied into a Word document. This contains the key datasets, decisions and results associated with a pooled flow frequency estimation. All of the above features, the use of the master peak flow dataset source, the identification and saving of any additional edited files, and the use of the project file and the HTML report should improve the auditability of given estimates and allow users to both easily replicate and assess other estimates. So this graphic shows a summary of the way in which data and methods are managed within WINFAP 5. So the datasets on the right-hand side here include the NRFA peak flow dataset and the data within the supplementary folder, which is selected when you initiate a pooled estimate. These stations are all held within the station manager and can be used within the flood estimation methods. As previously noticed, sites are identified by the site number. So if a station number in the supplementary folder is the same as the one within the peak flow dataset, then this will supersede it. If the site of interest has the same number as a station in either of these two datasets, then the station will be in the station manager, and the data associated with it will be used in preference to either of the other two data sets. Within a given project, any of these data sets can be edited, and these will be saved as part of the project file. These data sets are then used within the WINFAP methods to produce the final results. The QMED and growth curve estimation processes require a number of aspects to be identified, which include methods to be used, the data set utilised, the urban settings, and the urban parameters. These are then used to produce the final rural and urban flow frequency curves. The SAVE project contains all the information related to the datasets, methods, and results for the pooled flow frequency estimation method. The results, alongside pertinent information relating to the estimate, can be exported as a report. So I'm going to now take you through some of these changes and how they're implemented within WINFAP 5 within a short demonstration. When we first open up WINFAP 5, the first thing we'll see is this. We can link to the user guide if we want, and also our website and technical support is here as well. We close this down, and the first thing that comes up is the peak flow data registry. So the first thing you need to do is assign a peak flow data set to it. If you haven't got one already, there's a link so you can download it from their website. So I'm going to add one in. We're going to add in Peak Flows version 10. You only need to use the upper directory. It will then load in everything from the folders underneath. So it'll take a few minutes. What it's doing now is comparing what we've got in the Peak Flow dataset with what's in the manifest file to make sure that no edits have been made. Okay, so once it's loaded, we can see we've got details of the Peak Flow dataset name, and this is automatically provided from the manifest file. Where we've got it loaded at the moment, and it doesn't matter what you name this, it will still identify the correct Peak Flows dataset and whether we want to use it as default or not. So we can load in additional ones, so maybe next year when the next Peak Flow dataset come out, we can load that into here, and then depending on which one we want to use within our analysis, we can set it as the default. So once we've done that, we can say, okay, I'm done, and it's there. If we ever want to go back and look at that, we can just go into our options and look at our Peak Flow dataset, and it brings up that same screen. Okay, so we can also look at our return periods, and here's a list of sort of typical return periods that we might want to use. So I can add an extra year in here, so I'm going to just add in the 40 year, so we can see that now we've got an extra 40 year placed in here. If I want to set that as, for example, a user preference, so if I do lots of flood estimates using a typical set of return periods, which are not those originally set, I can do this as set as default. When I go back into WINFAP, it will identify me as the user, and it will use that default set. For a given project, I can change those return periods, and then if I come back and say reset those periods, it will go back to my default values. So you can change your return periods to whatever you're interested in for a particular project, and also have, for example, a favourite set of return periods that you'd like to use as well. So we also have a choice of project options and user options. Project options are valid for any given project, and user options are valid for a given user. So the project options that we have are these. We've got some general ones: use the FEH rejected periods of record, and the period setting the POT dispersion. We can also change the confidence intervals. In the main, these project options, most times you won't need to change them at all. So the other things we can change are our user options. These might be useful if, for example, you like to use particular color schemes or anything, and they will be valid for a given user. So if you change them here, save them, and then log back in at another time, it will retain those options in the same way that it retains your return period user options as well. So these are the colors associated with the AM and POT tables, and these are the pooling group colors as well. We've also got our donor options, which is the number of donor sites that we'd like in the QMED donor table. And again, we've then got our Peak Flow dataset options at the end. Okay, so we can also view the station manager. So the first time that you view this, it's going to take quite a while to come up because it's having to load in all the data from the 1,000 or so stations that are in the Peak Flow dataset. Okay, so we can see this is the station manager. We've got a table of all the data sets, and that will contain the Peak Flow dataset and the supplementary data set, and it may also contain the site of interest. So the peak flow data set is version 10, so you can keep very closely. It's very easy to see which peak flow data set we're using in a particular analysis and whether we've got a particular supplementary folder. We can say what we'd like to see here. So if I turn off the peak flow data set, we've obviously got nothing because we've got no supplementary data and no site of interest at present. We can say how we want to order it, either by station number or station name. Okay, so on the right-hand side here, we've got various tools which can allow us to export the sites, edit the sites, and create new sites. So the first one I'm going to do is export site. We're just going to export this top one here. So I'm going to export it. We'll export it. We're just going to call it test. So what this will do is export all the data that we have saved. So it exports not only the XML, but also the AM and .pot file as well. We can also edit the site. So if I select a site and then select edit, we come up with the single site dashboard, very similar to how it was in WINFAP 4 with a few small changes. We can edit any of the details in here. So for example, I could edit these details and that it's no longer suitable for pooling. If I then save that, it saves within the project. So none of the baseline files are changed at all. The information is just valid within this project and not externally. So I'm going to save that in the project. I could also change either the peak center threshold, the catchment descriptors, or the annual maxima. So we could go in, for example, and change this to 300. And then again, save that within the project. And I can use that data within the project. And that's all saved if someone else opens that given project. Now I can also export the site in a similar way to exporting a site from the station manager. So I can export it to here. So I'm going to call this test, but I'm also going to say that it's edited so that we know that I've edited these files. So again, it'll export the XML, and alongside that, it'll also be the AM and PT file as well. Okay, so we've exported that. So our third option is to create a new site. So we can do this either from the FEH web descriptors, or we can do it from scratch, so we can enter our own data. So first of all, I'm just going to import some FEH catchment descriptors. So that will then populate the fields as we like. So the unique site number, it's given by default. So the only thing we need to make sure is that that's not the same as any of the sites that we have here already. So for example, if I put in 2001 in here, it would then identify this station as the same one as this initial one here. And if I introduce it into a project, it will use the data here in preference to that data there. So it's important that this is a unique number. It doesn't look at any of the other data that we've got here. I can say whether I want it to be suitable for QMed and or pooling, and I can put some user comments at the bottom. And I can save that. And again, it'll save the XML, and it'll also save it as the AM and PT files as well. I'm just going to call this a new catchment. There we go, so it's exported that. So just so you can see what we've actually done, the first thing to note is here, because we edited this file within this project, this is now highlighted in pink with a star, which says that we've modified it. So if within a project we couldn't remember what we changed, we can just come back here and say, okay, well, that's definitely not the same as what we had within the peak flow data set originally. We've modified it, and it may or not be obvious from here what we've edited. Okay, so let's go back and have a look at some of these stations that we've imported. So this is the first one. So this should, when we import this file, should be exactly the same as what we had before. So we didn't do any edits to it, so it's exactly the same as what we have in the peak flow data set. So it's important to note that you can only have one site of interest within WINFAP 5, but you can have more than one instance of a WINFAP 5 project open. So you could have a number of instances of WINFAP 5. So we just need to, because of that, we just need to create a new project and then import one of the other sites. So let's look at the edited one. So this time, this one will have retained those edits that we made, so it's no longer suitable for pooling. And we've got our edited.am file as well. So this would be a useful way of saying, actually, I want to edit some NRFA peak flow data sets. Obviously, you can't edit those directly, but you can export the site and then edit those and use those as part of a supplementary data set. Let's have a look at the last one that we did. So if we go back and import this last one, which we called new catchments. So, and have a look at this one. What we can see is it's got the sort of the data set that we put in there before, we imported. We've got our user comments here, etc. What we've also got is an empty AM and peaks over threshold dataset. So if, for example, we have some dataset from a site that's not in the NRFA peak flow dataset and we want to use it within our analysis, we could create these default files like this and either edit this within the WINFAP 5 program by editing these files manually, or we could edit those externally in Notepad++. So that's a good way of overwriting, if you like, the data that we've got within the peak flow dataset. Okay, so those are the main features of data management in WINFAP 5. Changes to WINFAP 5 also include a number of method updates. The first of these is the incorporation of the BFI host 19 catchment descriptor. This was an update to the original BFI host equation with work completed in 2019 and is now used in place of BFI host. We've also implemented the recommendations from the Small Catchments EA project. For catchments under 25 kilometres squared, this will be the default method and will be optional for catchments up to 40 kilometres squared. The first update is to the suitability distance measure equation for small catchments, where the weighting on areas reduced and FPX and file have been removed. In addition, the donor number of stations for QMed is set to 1. Following work completed by Thomas Kelson, where a modified 3-parameter kappa distribution was found to provide, in many cases, a better fit to the AM data, this has also been added as an option to the distributions that are available. In terms of the growth curve, this generally falls between the GV and the steeper GL distributions, which are special versions of the kappa distribution. More details are provided in the help on this. The default distributions are now set to the GL, GV and kappa 3 distributions rather than just the GL to allow users greater clarity of the implications of using these different distributions. We've also increased the flexibility of the urbanisation procedures following feedback from many users. Some of these relate to possible inconsistencies between the QMed and growth curve urbanisation. First, we've decoupled the urbanisation, deurbanisation of QMed and the growth curve so that these are now independent of one another. We also allow deurbanisation of stations within the pooling group, potentially allowing users to use stations which are more urban than they may have been able to previously. By default, both pooling group data and at-site data will be deurbanised where available and where suitable for pooling. Also, by default, the decision as to whether to deurbanise at-site data will mirror that for the pooling group. On instigating a pooled analysis, a user will define the urban threshold. In practice, this is the URBEX 2000 value that a user is confident that the urbanisation algorithm can correctly adjust for. Whilst there is flexibility for a user to deurbanise, the following do apply. First, if the URBEX 2000 value for the site of interest is less than the threshold, then the user will not be able to treat the at-site L moments differently from those within the pooling group. This is unlikely to make a significant difference and does ensure consistency. However, if the URBEX 2000 value for the site of interest is greater than the threshold, then the user will be able to treat the at-site L moments differently to the pooling group. If a catchment is heavily urbanised with site-specific influences, this flexibility allows the user to apply case-specific settings. However, note that we're showing warnings if there are any inconsistencies between these. Now I'm going to demonstrate those methodological updates within WINFAP 5. Okay, so I've got a new WINFAP 5 project and I'm going to start by importing a site. It's going to be a gauge site from the NRFA initially. So let's go to a suitable for pooling site. I'm just going to import the Devrona Avoci. So this is a fairly large catchment. So when I open it up, although there's the option there to use small catchments, it's shaded out so we can't select it because this catchment is bigger than 40 kilometres squared. I can use a supplementary data folder though. So I'm just going to browse to that and use this supplementary data folder that I've put some new files in. So let's create that. Okay, so we've now got the pooled and QMed analysis dashboard as previous. It looks fairly similar to WINFAP 4. Before we do that, however, I'm just going to have a quick look at the station manager. And we can see that now we've got some more supplementary stations in there. So we can see that we've got quite a few supplementary stations in there. And we've got our site of interest as well. So if I turn that off, there we go. We've only got our supplementary ones in there. So we've got quite a few stations. It's very easy for us to see which stations are in there. as previously, if we've modified any of these, then they would also be flagged with a star as well. So as I said, this is fairly similar to WINFAP 4. We've got our pooling table here. There are a few changes to it. So the first thing is that we've now got both observed and deurbanised L moments, so the LCV and the L skew. And by default, it's the deurbanised L moments that are used in the analysis, and that's why these are in bold. We can change that down here by saying whether we want to deurbanise them or not. So if I untick that, we'll be using the observed values instead. Because this site has a fairly low Urbex 2000, lower than the threshold that we've set, which is 0.03, we can't have any inconsistency between what we're doing with the pooling group and our at-site data. So if I tick this, we also deurbanise the at-site L moments as well. Obviously, if I say not to use the at-site data, that's it's not included here. So we can see also here that I've got an extra station in here. Although the data set is actually the same as the Devron, we've called it a different site number, so it identifies it differently and it's added it in as an additional station. That's really just to demonstrate the supplementary data folder usage. In our catchment descriptors, we've got the BFI host 19 that's also presented as well. Okay, so if we're looking at this pooling grouping practice, we'll probably want to remove or add some stations. So as previously, we highlight it and can reject the station. Now, however, we have a list of these underneath so we can see which are our rejected stations. I can also reject that supplementary data folder. And then if I decide actually I need to add something back in, I can go to add station. And we've got, first of all, we've got the rejected stations are pale, so you can see which ones you've rejected previously. And also they're flagged as to whether they're modified or from your supplementary data. So I'm just going to add this one back in. Okay, so they're the main features of the growth curve table. We've also got similar changes for the QBED table. So if I select not to use at-site data and look at using donor adjustment, you see the table as before. We've got a couple of additional fields in here. So we've got the BFI host 19 is presented. We've got, as previously, the observed and deurbanised QBED. By default, we're selecting to use the deurbanised value. We can obviously untick those on an individual basis if we want to. We're also presenting the catchment descriptors, urban and rural values as well. And as previously, if you want to change what you're using from your sample data set, you can. And also we're flagging up here whether it's from the supplementary data or whether it's been modified as well. Okay, so the other main differences are we can obviously select the CAP3 as well, and by default that is selected, so we get results from it. You can obviously remove it as well. We can also generate a report, and this will be in the form of an HTML document. And we can see here that it contains pretty much all the information we need to do a good audit of a given flow estimate. So we know which version of WINFAP we've used, which peak flow data set we've used, and whether we've used any supplementary data. We've got all the general details of the site, any settings, whether we've used at-site data or not, any urbanisation settings, the growth curve settings and the QMED settings. So here we're not using our at-site data and we're using the donor stations. We've got our growth curve pooling group with a list of the rejected stations underneath, all the details of the growth curve L moments and the fitted parameters, together with the goodness fit and the heterogeneity. We've then got our standardised growth curves. Following that, we've got the QMED data, so what methods we're using, and then we've got a list of our donor stations and a list of our unused donor stations, so we know which ones we've not used. And then finally, at the end, we've got our final flood frequency curve that we've used. So this HTML could be imported into a Word document or saved as a PDF as well, but works as a useful audit of a given flow estimate. The diagrams down here are pretty much the same as before, although we have added functionality for copy and pasting, so there should be increased functionality to copy and paste any charts. In addition, on the site growth curve, we've flagged up the pooling group growth curve and also highlighted the names of the stations for the other growth curves as well. I'm just going to have a quick look at the single site assessment. The main difference here is that we've added in the kappa distribution. So if we say select distributions, we can see that the kappa with the L median method is added. And if we have a look at those on the flow frequency curves, we can see that as specified earlier, we'll get the GL is a fairly steep curve. The GV at the longer return periods is less steep, and then we've got the kappa 3 in the middle, with these two being specialized versions of the kappa distribution. So more details are given in the technical guidance, but if we look at the station fittings, we can see that the kappa 3 is a special version of the kappa distribution where we've set the H value to minus 0.4, which was found to be the best value for fit in the UK. So we know what we've got in our pooling group here, so it would just be useful to, let's just save this project. So we're just going to save it very quickly. So it is 9001. So we're going to save that as a special XML file. If we say new project, so we close everything down and then we open that project up. Let's have a look. So this should have retained all our information that we had before. So if we pull up our pooling group, we've got our rejected stations here. We're using our donor stations here. And all the decisions we've made about what we're doing within our flow estimation is in there. It's also got our supplementary data in there. And even if we didn't have that supplementary data available, that is saved within the project, so it will be utilised. Okay, so I'm just going to start a new project and we're just going to quickly import another station. So this time it's not going to be suitable for pooling. It's going to be station 37033. I particularly picked this one because, first of all, it's a small catchment. So we can see how the small catchment method looks. So it says use small catchment recommendations by default. So that's ticked. We can untick it if we want. It would be unticked by default if it was between 25 and 40 kilometres squared. So let's just create that. Okay, so here's our pool growth curve for this station. If we forget what we've used, again, we can just go into review our pooling group and it'll tell us that we've used the small catchments just in case we've forgotten. So as I said before, this is a strongly urban catchment. So we've got a warning just to say, don't forget that this Urbex 2000 is greater than your pooling limit. If we decide to use the site data then, it's obviously deurbanising. We can see it's had quite a big impact on our LCV and our LSQ. So we'd need to be comfortable that we think that is capturing those differences correctly. And that's why this warning is here, just to remind you that if you're using this, then you need to be careful about whether you want to use the observed or the deurbanised. We've also got a warning here about using outside data because it's designated as not suitable for pooling. If we then decide that we don't want to deurbanise our outside moments, we'll then get another warning. And this is to say that here we're using our observed and here we're using our deurbanised. Now, because it is heavily urbanised, we're allowing those two decisions to be different. But obviously those warnings do come up just to make sure that you're comfortable with those decisions. Those warnings will also come up in the report. So if I now open up the report for that, create this report. As we come down, we can see that first of all, the station is designated as not suitable for pooling, and also the application of deurbanisation is inconsistent. So any warnings will be shown when we're doing our flow estimation. So hopefully, following the presentation on the differences that we've made to the data management and the presentations on how those have incorporated within WINFAP 5, you'll feel comfortable in opening up WINFAP 5 and being able to utilise it in the best way possible. Thank you for listening.